This is the eLearn Podcast. If you're passionate about the future of learning, you're in the right place. The expert guests on this show provide insights into the latest strategies, practices, and technologies for creating killer online learning outcomes. My name's Laddick, and I'm your host from OpenLMS. The eLearn Podcast is sponsored by eLearn Magazine, your go-to resource for all things online learning. Click-by-click how-to articles, the latest in EdTech, spotlight on successful outcomes and trends in the marketplace. Subscribe today and never miss a post at elearnmagazine.com. And OpenLMS, a company leveraging open source software to deliver effective, customized, and engaging learning experiences for schools, universities, companies, and governments around the world since 2005. Learn more at openlms.net. Hello, everyone. Welcome to the eLearn Podcast. I am coming to you live from OpenLMS, the last recording of the year, because it's December 27th, 2023. I mean, I can smell January 2020. No, it's December 27th, 2022. I can smell January 2023 so well that I'm already replacing the year. That's fantastic. My guest today is Kristin Torrence. Hello, Kristin. How are you today?
Hello. Doing well. How about yourself?
I am well. I know that, you told me this already pre-show in the green room, but where do we find you sitting today?
I am located in Southern California in a city called Corona.
Corona? I've never heard of Corona, California.
Well, ironically, we moved to Corona during the coronavirus pandemic.
I know that was definitely right. The next thing I was going to ask is that had to be the worst town name to have.
It's so funny.
Wonderful. Kristin, you are the head of learning engineering at a company called Tailspin. Why don't you tell us about yourself? Give us the 30 to 60 seconds on what you do at Tailspin and how you got there.
Sure. Yeah. So I have a background in cognitive science, game-based learning, and instructional design. And so before working at Tailspin, I worked for an ed tech company that created educational games for kids. But since then, moving to Tailspin, we create virtual reality trainings for enterprise corporations, so for adult learners. And, we develop and deploy VR as well as have a no-code authoring tool.
Oh, okay. Very cool. So I have to ask you, I know this wasn't something that you may be prepared for, but what was it like moving from sort of gamification for kids to adult learning? Was that a big mental shift? Is it a really different process or lots of the same things?
I would say it's lots of the same things, right? So, for kids, I think the only difference is for kids, you're really focused on designing alignment with standards for science or Common Core standards. Whereas, for adult learners, you're really focused on solving problems or for learners to apply on the job. So.
Okay. All right. Cool. Very cool. So my first question for you is, what is learning engineering? And now, I have had this is like the 200th podcast episode. I don't even know what number this is. And, we've been reporting on online learning for literally since 2009. But this is the first time anybody's ever called themselves learning engineer that I've talked with. So tell me about how do you define it? What is learning engineering?
Yeah, so learning engineering is an evolving discipline, so it's totally fine if you don't know how to define it. I think
well,
many
I'm just
people
feeling
don't.
stupid, because I'm like,
No, not at all. But there is a group that had been working the past couple of years on defining what learning engineering is, and it's defined as both a process and a practice that applies the learning sciences, uses human-centered and engineering design methodologies. And also uses data-informed decision-making to help support learners.
And so are we seeing more and more, could I go get a degree in learning engineering right now somewhere? Or?
You actually can. Yes, I do believe there are 2 degrees offered in learning engineering. One, I believe, is at Boston College. I think the first and ever learning engineering master's program is at Boston College. And I know that there's also a program at Carnegie Mellon that is fairly popular as well.
Super cool. Wow. I guess the East Coast has the as the lock on new things around learning, I guess.
I will say that, learning engineering being a process and a practice, brings together a lot of disciplines that so I wouldn't say that you need to get a degree in it. You could absolutely apply learning engineering as an instructional designer, already having an instructional design credential or degree, or even if you became an accidental instructional designer and are working on creating learning solutions, you don't have to get a another
Mhm.
degree. What you can do is just adopt those practices and integrate them into, your processing practices on the job.
Can you give me a specific when you say it's a process as much as a practice or a process?
Mhm.
What is like? Could you give me like a specific around what does that mean? Like it is a process. Like,
Yeah, of
Mhm.
course. So learning engineering always starts with the challenge or the problem or obstacle that you're trying to overcome, right? So it's like a design challenge. Essentially, it's what you're designing for, to either improve learning or learning outcomes. And starting with the problem, then you sort of investigate what that problem is, figure out what the root cause may be, and then design and make design decisions depending on what that problem is and what factors can be improved to then produce promising outcomes.
Mm. All right. So take me there. You're a tailspin. You guys are focused on VR essentially in the adult learning space. We've had several people on the podcast talk about the particular applications of VR in that space. But how are we? How do you apply learning the sciences? Like learning engineering and whatnot. This process to the development of VR in your practice.
Yeah, that's a great question. And I think, just wanting to focus right now on, applying learning sciences in general, to virtual reality. So, really thinking about what we know about how people learn and what those conditions are for, like, or environmental conditions, situational conditions, that create improved learning, right? And
Okay.
so ensuring that we're sort of designing for that. So, for instance, virtual reality, um, we think a lot about situated cognition, right? So we're situating learners within a virtual reality space contextually, right? And
Hmm.
so, one of the things we want to think about is, how authentic are the environments that we're putting learners in, right? Do they seem realistic, right? Do perceptually and conceptually, do learners are they able to feel like they're in this space? So that's also something that we start thinking about when it comes to situated cognition, for instance, to help with transfer on the job. We want learners to become familiar and be able to detect contextual cues in virtual reality as they can detect them, in the physical world rather.
Hmm. Sure.
um, Things like experiential learning. We want to really think about guided discovery within the virtual reality space, right? Learners are active agents when they're in
Mhm.
virtual reality, just as
Sure.
they are in the physical world. And so providing them with this agency, providing them with the opportunity to interact and discover things in the world, I think is really important, right?
Mm.
The, I think that's the beauty of virtual reality is that, as they're interacting with the world, they're uncovering these cause effect relationships. If I use a tool on this machine and I do it in the wrong way, what are the consequences of that? And I think virtual reality creates a really safe space to be able to experiment with those sorts of cause and effect relationships and have
100%.
learners experience that and make those cause and effects relationships very salient to them.
Absolutely. Can you juxtapose that for me against, creating a reality that is more sandbox in nature? So one of the things, like the thing that's springing to mind right now is, the Minecraft phenomenon,
Mhm.
right? Where people have created literally cities, towns, in machines, and they've used that sandbox to develop some pretty extraordinary stuff.
Yeah.
Whereas you're talking about a learning experience where it's very thought through about
Mhm.
the learning outcome that you want to get. What are the considerations in those, and is it always a preferred to have it constrained, to where you want to go in that learning outcome, or is a sandbox experience something that you also play around with?
That is a great question. So, I don't have much experience designing for more sandbox type learning experiences in virtual reality. I will say that they do have uh, there is some really great affordances with that, right? There's this feeling of freedom and autonomy and being able to really be that sort of active agent and chart my own path within the world and play with things. I will say that when it comes to learning, we do want to guardrails probably isn't the best
Hmm.
phrase for that, but you know we kind of want to constrain the amount of time learners are in the virtual reality headset simply because it could cause fatigue. And
Hmm.
so we definitely want to limit it to around like 15 to 20-ish minutes. That typically is the optimal time, right before learners start feeling a sense of fatigue, before maybe their eyes get a little bit
I
tired.
really wish that you would tell that to my 14-year-old. No, no, I mean, me personally, I start getting car sick, like motion sickness in like 3 minutes. But yeah, like, wow. Okay, so 15 minutes, like per
Yeah.
session, you're saying?
I will, yes, 15 minutes about per session. And so, we definitely, when we're thinking about designing for learning, want to use that time most optimally. And
Mm,
so, and there's also something about, learners having really clear goals when they're in the virtual reality space. I think research has shown that having clear goals, sense of interaction and autonomy really helps having a sense of presence within the virtual reality space. And in essence, could really help induce the sense of flow and help them, learn as they're moving about the virtual reality space and really engaging with either the objects or the virtual humans that they're interacting with. And so I'd say simply because of the time constraints, we really want to optimize the amount of time learners are learning intentionally, right?
mm.
And so we want to present the information or the scenario to them in a really sort of targeted way to just optimize the amount of time that they have in learning and in being actively engaged.
Wow. It leads me. So one of the things you mentioned this maybe like 5 minutes ago, where you're talking about building out a scenario where you're using a tool maybe on a machine or something like that. This is a super deep, like in the weeds, sort of geeky question. Like, how many like fail scenarios do you have to build in that type of operation? Let's go down the truly, like you're dealing with a machine, you're fixing something,
Sure.
right? You want to turn the screw the correct way and it works. Okay, that's the win. That's the learning outcome. But like, okay, like how many different like ways do you say, nope, you did it wrong? Like, is that really, I mean, are people spending hundreds of hours programming all these different scenarios, or how does that work?
Yeah. Well, I think there could be many ways that things go wrong, but I think there are some common ways
Mm,
that things typically do go wrong, and common sort of avenues learners take and maybe have misconceptions about how something is supposed to work. And so we definitely want to hone in on what some of those common mistakes are or misconceptions. Um, and, of course, if there's probably a circumstance where the learner can like run around the room and then have something go wrong, but like the chances of that happening is probably slim to none. And so we definitely
mm,
want to focus in on the most common types of misconceptions or mistakes learners make, just to kind of capitalize on that and being able to see, these are some common mistakes and these are some of the consequences that occur because of these mistakes, and have learners really recognize that, through play and uncover that, and hopefully have that resonate with them as they sort of sit with that consequence.
mm, cool. What I mean, everybody who's listening to the podcast right now has heard of human centered design,
Mhm.
right? And you did a great job of explaining, how engineering and engineering process comes into the learning, developing learning. How do those get applied to VR specifically? So
Mhm.
how do you bring human-centered design into that, et cetera? Is it the reality, that sort of, as you said, creating that environment, or is it, I don't want to put words in your mouth. You're the expert here.
Well, there's so much with learner-centered design or human-centered design. And I want to say, like, I think one of the most powerful tools that we use are personas, right? Just for learner personas, but then also character personas, right? Because learners are in this world and they're often engaging with virtual humans or even getting coaching feedback from a voice that could have a personality, right? And so to help things feel real and authentic, especially virtual humans that we're seeing, we want learners to feel like these people or these beings are real people, realistic people that they often come across in their everyday life or on the job. And so I would say learner personas are an essential tool for
Mm.
designing virtual reality, and also character personas as well. Because one of the things you can do also is set the interests of character personas against the interests of learners to help challenge them and really help them overcome and build their skills as they're engaging with one another.
So let's just take that scenario. As you are working with a new client or with a new uh, scenario that you're building, what's the pre-development research time that you're looking at? Like, how deep do you need to go inside a team or an organization in order to sort of pull those personas out or get that understanding of what might work against what, or like how to, A versus B, that kind of stuff?
Mhm. Yeah, well, I would say that the timing of that is quite different, just sort of depending on how novel this persona is to what we're used to creating, or how fleshed out the our
Mm.
understanding of learners and the people that they interact with on the job are. Those personas might already be created within an organization. But I would say, if starting from a blank sheet, there's definitely you'd want to have some subject matter expert interviews, maybe have a focus group, maybe even look at system data to help understand learner demographics or anything like that. And so I think you could take a lot of time if you have the time. But I
Mhm.
think oftentimes, we're sort of limited on the amount of time, effort, and resources that we have, especially in that analysis discovery phase, that we just have to work within our constraints.
Sure. Mhm.
But I would say that having really defined and representative learner personas is probably one of the most essential things that you can create for virtual reality.
Fantastic. I'm just, there's about 10,000 questions I want to ask about that, but then I'm going to steal all your company secrets about how you build stuff. Um, so you build, so we're using this design process, a human-centered, design process to get to VR and everything like that. What do I do how do I know if I'm successful? Right. So
Mhm.
how does your team either go to a client or work within, whoever you're delivering for, to understand what needs to be improved, what worked really well, what outcomes were effective, that kind of stuff. Like, what do you use to evaluate the effectiveness of the VR that you build?
That is a really great question. And you know what? I would say, virtual reality development, there's so many facets to it, right? You are in design phase for a lot of it. But then you're also, deploying it, and there's that impact
Mhm.
phase. And I want to hit that, success might look very different at those two different stages. When we're in the development phase, we're often looking at, is our display and interaction fidelity or our scenario fidelity, is that high, our task clarity, right? So are learners getting confused when they're in the virtual reality space? Do they know exactly what they need to do? Or how valid and reliable are our assessments within the virtual reality space? So those are some things that I think during the design phase you definitely want to test and measure and investigate. But then when your solution has been deployed, that's when you're really looking at impact, right? So you're looking at those learning outcomes. You're looking at transfer on the job, and is that translating to business outcomes, or are you having indicators of decision making competence, things like that?
Mm.
So does are you really seeing that learners have internalized and integrated what they've learned into practice, into their behaviors on the job? So that's what you're really looking for in terms of success and when it comes to impact of the learning.
So there's really like a with headset, without headset, right? Like so kind of two different phases of evaluation that happen there. Yeah.
Absolutely. And when thinking about within headset, that's where we're really thinking about things like formative feedback, summative assessment. And I think those are so essential because you want that sort of feedback, or measurement, and to be delivered to learners in a way that they understand what they've done correctly, understand where their growth areas are, how it could be improved, and then hopefully encourage them to try again and replay, right? So that, and have that their feedback be very representative of their actual abilities, right? You want
Mm.
that to be valid. They're the in let's say just in VR assessment to be valid and reliable, so that when they can master something in VR, then that tells them that, then I could let me try it in the physical
Sure.
world, because the VR training is telling me that I have enough competence to be able to act it out in the physical world, and hopefully you'll have opportunities in the physical world to do maybe practice runs, or like observed field observations
Mm.
with someone like a manager or someone more skilled to help also give you feedback and um, you know help you really hone and develop your skills further.
I want to know, like, have you, like, what's the craziest or most interesting feedback that you've received when someone's moved from that, hey, again, I'm gonna just take the machine scenario, like,
Sure.
I was working on the machine in the VR, and like, again, I got that feedback that hey, I knew how to repair this, or I knew which part went where, and then they went to the field and they're like, you know what, it worked, but here's this, like what is it, like the paint looked different, like the tool didn't, like is there anything that you could like be like throw on the table there, is like what's the weirdest feedback you've got?
Yeah. So you know what I would say, there's sometimes a difference between um, how people. Well, let me take like a more hard skills approach to this, like controls.
Mm.
Lots of people are often surprised how intuitive controls are in virtual reality, and how those same sort of mechanisms mirror what your hands do,
Mm.
when you're working on a machine, which is, I think, definitely part of the design, that's intentional.
Sure.
There is research to say that you may have heard of the uncanny
No,
valley
what's that?
there.
I've never heard of that
Oh,
one before.
so uncanny valley is, it's when the computer generated image, often associated with people, it's when human likeness is so realistic that we get turned off by it.
Right, because you're
Yeah,
like, oh, this is too real, and there's
yeah,
a,
it's a
yeah,
little bit
yeah.
too real, but then there's something about them that we know is like, fake, and
Uh-huh.
we get really put off by it, and it's just a natural mechanism, like biological
Sure.
mechanism of
Hmm.
ours. There is an uncanny valley for interactions,
Mm.
which is, I
Mhm.
think, fascinating, right? And so, and research has shown that for virtual reality, if your interactions, or the way you're asking learners to sort of move their hands or manipulate things, is not aligned to how they would intuitively move in the physical world, then it actually causes increased cognitive load.
I gotta say, like you kind of fell right to where I went, like that not fell, but like that's where you were explaining because my next question was like muscle memory, right? Like
Mhm.
I'm just thinking, especially when we're thinking hard skills, e- everything from, operating on a person to fixing a telephone wire, whatever. Like I'm a guitar player. One of the things that you learn is that your body remembers things
Mhm.
subconsciously that, like I don't think of chords when I play them, right? I'm thinking some, and so I'm wondering, gosh, how do you design things? You just have to get so exact so that you're mirroring those things so that muscle memory is the same. Is that how it works? Or
Yeah, I think that's definitely something that we do strive for because a lot of what we do, especially for virtual reality, where people are trained to do procedures with precision, right? We want them to, with repeated practice, do the same thing over and over again. So these movements and these decisions become almost automatic.
right. Hmm.
So yeah, that's definitely something that in the design phase we're really intentionally trying to replicate is how it's done in the real world and how can we make that intuition mirror both in the virtual world and as well as the physical world.
Yeah, and I would think that when you're dealing with like sort of safety scenarios or first responder scenarios, anything that's an emergency, like that's you got to get it right.
Oh, absolutely. And I like to say that we really do design for schemas, right? Because in virtual, like we know we're so intuitive with how things work in the physical world. And we definitely, because in virtual reality, we're trying to replicate these authentic scenarios and these situations and have learners pick up on real contextual cues, we absolutely need to design for schemas and understand how learners or people how they perceive things and how they think things should work because the way that they work in the real world needs to mirror how they interact and work how things work in the virtual world, even when it comes down to things like physics and what can and can't be picked up, or ensuring that a magnet acts as a
Wow.
magnet
Hmm.
would, or
Hmm.
if something has a hanger that you should expect to be able to hang something, and so it's really sort of digging into people's, not just their perceptual understanding of what they should perceive in terms of stimuli, but then also their conceptual realism, and really trying to replicate that in VR.
Wow. I'm the level of detail and nuance that you can continually refine and tease has just got to be amazing. So my final question for you in that regard, since we are now coming to the close of 2022 and we're looking at what's next for learning engineering in VR? What's next for, like there's many people who said, hey, look, VR is absolutely fantastic, but there's sort of this limited nature of things that we can teach in VR, or et
Mhm.
cetera, et cetera. Like, give us your opinion about what do you see in the near term, 6 to 12 months out, and
Yeah.
what's your hope for, how things will continue to evolve?
Yeah, that's a great question. And with learning engineering, everything is really about investigating and testing, and to really discover what things are working, what's not working, and really optimize what's working, and then fix and refine what's not, right? And so I think in 2023, there's so much opportunity now in the marketplace in terms of affordances of VR headsets and things I'm thinking about that will enable that sort of investigation, right? Are things like eye tracking, which is
Mhm.
becoming ever more prevalent in headsets. There's a headset now that can detect cognitive load and
Mhm.
extraneous cognitive load that is imparted on a learner. And I think as we start developing more and using these sorts of tools, really looking at the data, and then understanding what about our designs are maybe imparting an extraneous cognitive load on learners, that we can then help mitigate and optimize for that. I think there is a lot of opportunity to come in the future around the types of data that we collect and what that will enable us to learn both about our learners and about the contexts, situations that we're really thrusting learners into, and how we can learn and continue to sort of optimize and figure out what's working in VR. Like, really, what are those best practices, right? In terms of how we can really promote deep learning
Mm.
and encourage that sort of motivation and really help facilitate like learning and transfer. And I think that with the more data and the more affordances of the technology, um, the more we'll be able to really uncover and really figure out how to leverage all of that for deeper learning.
Super cool. Kristin, sorry about that.
It's okay.
Kristin Torrence, you are the head of learning engineering at Tailspin. I can't thank you enough for taking time out of the last few days of the year here, out of your time to speak with me today. Really appreciate it, and I really wish you all the best for 2023. Thank you.
Thank you so much for having me. I really appreciate it. And looking forward to 2023.